and activities. So, sir, please.
Sure. Thanks a lot. So, uh, as this is a ACM event, and this is a basically specific event or by ACM Pune chapter, I will just introduce about the ACM India, and briefly about ACM Pune. So ACM, the Association of Computing Machinery, it's a premier global community of computing professionals and students, nearly 1 lakh members in more than 170 countries. They interact with, in fact, more than 2 million computing professionals worldwide. That's basically the statistics is. Now, apart from publishing research journals and magazines, ACM brings together computing educators, researchers, professionals to inspire a dialogue and share resources and address the field's challenges. Now, ACM chapter is actually one of this particular initiative where the goal and intentions are they act as a local neighborhood of ACM. ACM chapters act as a local neighborhood of ACM, and so we have ACM Pune, and there are many other in other cities in India. So ACM professional chapters, in fact, as they act as a hub of activities for ACM members, generally they provide the seminars, lectures, learning forums, and basically there is a networking opportunity that you get across with the experts across the computing spectrum. Now, one important part is that chapters typically focus on information and insight not easily found elsewhere. That's why in this world of internet, it is very important that we should talk about the topic. This panel discussion is one of that actually, that what the industry expects and what the academics are doing and how basically we can collaborate together. That's basically we need to really look at it in a different angle than what information is available and insights are basically found elsewhere. Coming to ACM India, now ACM India actually is, as I mentioned, that ACM India has lots of ACM chapters, and there are ACM chapters which are professional chapters and the student chapters also. In fact, out of 1 lakh members worldwide, about 10% are from India, remember that, and half of them are students. ACM India is in fact spread across the country, mainly due to its chapters, as we are one of the chapters. And as a member of this chapter, you get access to this distinguished speaker program and eminent speaker program. That's what ACM chapters drive. So we also have a best student chapter award. In fact, ACM India also has a best student chapter award, and in fact, some of the institutes like PICT and PCCOE and Chitkara University, they know about this particular awards. They have been recognized this year or last year. There is another initiative from ACM India, which where we organize summer and winter schools for students in different research areas in computer science. And in fact, faculty of these schools is drawn from prominent academic institutes. And there are special interest group also, and there is a coding context also conducted by ACM India. To summarize on this particular thing and highlight one more important part of this particular ACM India is where there is something special for girl student. ACMW is actually, they work for empowering women in computing, and there are many initiatives for girl students. There is a Lady Ada programming competition and hackathon for girl students. There is also one of the summer school which is exclusively for girl students, in fact. So there is a partnership with Anida Borg Institute for Grace Hooper Celebrations India, which is the largest gathering of women professionals. Now I will just take 2 more minutes to talk about the Pune professional chapter. And one of the things that we are doing as a part of Pune professional chapter, that we definitely take a lead from whatever the ACM chapters and ACM India are supposed to do. And we will, in fact, we intend, in fact, to operate in this particularly for and exclusively, maybe you can say, for educational and scientific purpose. And this is basically, we don't want to do a specific kind of or the maybe general kind of seminars or general kind of speaker programs, but we intend to actually concentrate on certain things which are interest of both the academic and the industry. And that's what our interest is at this, and that is what we have actually thought about in this year. So definitely, as I mentioned, that we are in fact deriving from ACM chapter and ACM India. Inspiration we are taking from them only. So there are a lot of things that are common that actually that are driven. Coming to the current chapter, I mean, who are the basically members of this chapter? I am Vivek Buzruk. Then we have a vice chair, Umesh, who will be talking about this particular today's topic in a brief after me. Then there is a chapter secretary, Dr. Gitanjali Kare, who introduced us or who welcomed us. Mr. Nitin Patil, who is a professor from SP University, who is a treasurer. There is a Nikhil Gupta, who is from Monimo. He's a founder of that. He's actually helping us a lot in designing and the overall basically content. He's a webmaster for us. There are other core committee members, one from the TCS, Vijayanand, then there's Sonia Garcha, then Kapil from PCCOE. So this is basically the Pune professional chapter as on today. So I will hand over to the Umesh to take over and talk about today's topic and brief about everyone about what we are going to discuss. Thanks.
Thank you, Vivek. Good morning to everyone. I'm Umesh Puranik, as Vivek introduced me. So I'll just briefly talk about what we are going to cover here, what is the intent of this. As all of you know, it's no wonder that with changing hardware technologies, advances in processors, and massive explosion of computer usage in everyday life, the programming languages also have evolved over the years. Some of the older ones are almost extinct and new ones are rising sharply. There are a lot of new frameworks and libraries coming in. There are paradigm shifts in programming. And with this, there is basically a plethora of programming languages, frameworks to learn. A professional who needs to keep up, who needs to remain relevant all the time, is always wondering what he should learn next, or should he simply focus on what he already knows and keep building further, with obviously the danger that at some point he would become irrelevant and obsolete, and he wouldn't be able to keep up with the industry. For the students, again, the same question happens, what they should learn, how they should learn it. And the even more fundamental part is, shouldn't they have very strong fundamentals in computer science with deep rooting, so that when they go to the industry, they are better prepared for that. So with this, we have to look at what languages the professionals as well as students should learn, how they should learn it, and we'll talk about the plethora a little later. I'm sure the panelists, they are industry veterans, they are experts in academics, and they would guide us through this thing. Next slide, please. So in today's panel discussion, our goal, the focus would be on this, that guide the students how they should learn, guide the developers about the technology changes. Many of them are aware, but as you know, a big chunk is not simply keeping up or keeping aware of the changes in the industry. For example, typical system programmers or embedded system guys, they wouldn't really know anything about JavaScript, Kotlin, and all these new frameworks that are coming. I'm sure many of them even wouldn't know about Rust. They would be still sticking to the older C++ paradigms and languages. So at some point, they also need to know these things, as well as in the changing environment. It's no longer a siloed domain that you work on. You could be working one day on systems programming, another day as an extension. You could be working on cloud technologies. And obviously, the same languages are not applicable or efficient in use in both these places. As a result, your spectrum of expertise and programming languages always needs to expand. So that is for the developers. As I said earlier, for the students, their main learning channel is through the institutes, the academicians. And the academicians here, they would guide us and tell us how exactly the industry, that they are preparing the students for that, as well as what they see as the trends. And we brought these panelists together from industry as well as academics. with the sole reason that getting these two streams together would basically prepare both the students and professionals in a better way. It will also tell us how the industry needs the skills gaps to be bridged, and how the academics could make sure that the students are better prepared with that. So as I said earlier, these we are good. We are actually thankful to have these great panelists with us here. And Professor Kale would introduce all of them to you.
Yeah,
Over to
thank you.
Professor Kale.
Yes,
Thanks.
yes, yeah. Thank you very much, Umesh, for handing over this. So it is in fact my honor and privilege to introduce our eminent panelist and moderator, which is excellent blend of academics and industry. So today we have with us Professor Abhiram Ranade, who is moderator of the panel. Dr. Ranade is faculty at IIT Bombay since 1995, and currently he is a professor in Department of Computer Science and Engineering. His research interests are algorithms and combinatorial optimization. Professor Ranade, Abhiram Ranade received a BTech degree in electrical engineering from IIT Bombay in 1981 and doctorate in computer science from Yale University in 1989. He worked as an assistant professor of electrical engineering and computer science at the University of California, Berkeley during 1988 to 1995. So welcome, Professor Ranade, and thanks for accepting our invitation. We have with us Dr. Ravindra Kumar as panelist. Next slide, please. We have with us Dr. Ravindra Kumar as panelist. Dr. Ravindra is working as principal scientist at TCS Innovation Labs, Software R&D Tata Consultancy Services. Ravindra has done his MTech from IIT Madras and PhD from IISc Bangalore. His area of interest are program analysis and synthesis, first testing, specification mining, and architecture recovery. In last 25 years, he worked as programmer, designer, and solution architect for large-size global banks and financial institutions before moving to the research. So welcome, Dr. Ravindra Kumar, for this panel discussion. Next, we have with us Dr. Varsha Patil, who is academics representation. So Dr. Varsha Patil is currently head of Computer Engineering Department and vice principal at Matushri College of Engineering and Research, Nasik. Madam is chairman Board of Studies Computer Engineering at SPPU Pune. Madam is working as advisory board member at various autonomous institutions. She has authored and co-authored many books and research papers. She is very passionate academician and leader. Madam has done her doctorate in computer engineering and did her master's in computer engineering from COAP, Pune. And she has also done MBA HR from Pune University. So thank you very much for joining us, ma'am, and welcome for this panel. Our next panelist is Mr. Rahul Ekbote. Mr. Rahul is Unit CTO and Head Enterprise Architects Group at Persistent Systems. Mr. Rahul is having 30 plus years of rich software industry experience. His technical interests are continuous learning, programming languages, and working on full stack enterprise software problems. Rahul is also working with academic institutions in defining computer engineering curricula and guiding the engineering students through various sessions, webinars, and seminars. So welcome, Mr. Rahul Ekbote, and thanks for accepting our invitation. Our next panelist is Mr. Sujit Karpe. Mr. Sujit is a co-founder and CTO of IMOCA. They have started IMOCA in 2015 in the domain of digital skill assessment to help companies hire job fit candidates faster. He holds 2 patents in the domain of pseudocoding. Prior to IMOCA, Sujit worked with IBM and his first successful venture, Radix Business Models. After 6+ years with Radix, he moved ahead to start IMOCA. So welcome, Mr. Sujit, and thanks for accepting our invitation. Before starting with the panel discussion, there is important announcement. Please post your questions through QA window. Through that window only you post the question. Don't post it in chat because it is very difficult to take from there. And all the questions will be taken at the end of the session. So welcome all. And now I hand over the session to Professor Ranade and panelist team. Thank you very much.
Okay, thank you, Mrs. Kare. It's a pleasure to be here, and I'm grateful to the chapter to organize such an important discussion. I think the plan roughly is that there will be an opening statement, maybe about 5 to 10 minutes. So please keep it short, because I think we would like to have a lot of time for discussion. So I think we can just get started. Mr. Buzuruk, would you like to say anything about the format, or we can just get started immediately?
Please get started, sir. Thanks
Okay.
a lot.
Okay. So I think we can go in any order, but maybe we can go in the order in which people were introduced. So I invite Dr. Ravindra Kumar to make an opening statement, give us his views regarding this entire subject. And I think you don't have to give complete detail. So stick to the time limit, and of course you will get a chance to describe more later on. So please, Dr. Ravindra Kumar.
Yeah, so while I have worked as an enterprise architect and as a designer, so I used to work largely with legacy language and their modernization onto modern programming languages like Java and other framework. But of late, from last 7 to 8 years, my focus is predominantly analyzing programs and recovering artifacts from the programs. And of late, I have been working on a topic called program synthesis, which essentially is today, it is some form available in some of the, in automating the end user programming. For example, if you take Microsoft Excel, there is something called flash fill, if you have observed, which can actually generate on the fly program by taking the examples, some of the examples that you provide. So programming actually is increasingly becoming getting automated. Okay, right now it is focused predominantly in end user programming domain, but going forward, there is I see that there is a significant changes in the way we program. Machines do a lot of coding. Actually, that's what is going to happen. The program synthesis is all about how machines write code. Okay, so while machine learning getting better and better, the way that we give specification, I mean, if you look at human programmers, their main ability today is that they can take informal specifications and can convert into programs, whereas today machines cannot do that. I mean, machines require a degree of sophistication in terms of specifications. With program synthesis techniques, which can take inputs in form of examples, they can infer the program, and the programmer's job is to more interact and tell machine this is correct or not correct. Okay, so with advent of machine learning, NLP, and these techniques, even some of the natural language specifications are also understood and code is emitted. For example, this codex that recently has come up actually take natural language and convert into these programs. But all these programs typically does very small functions, but we expect there is still some more time for them to reach to the enterprise level. But this is going to happen. In that context, what would be the role of a programmer and what are the kinds of skills students and developers need to learn is a very interesting discussion. I would be very happy to provide my inputs. I'll stop here.
Okay. Thank you, Dr. Ravindra. Perhaps I could request Dr. Varsha Patil to make her statement. Dr. Varsha Patil.
Madam, you are on mute.
Yeah, thank you, sir. I'm Professor Varsha Patil, working as an academician since last 30 years and currently involved uh, contributing at university as Board of Studies Chairman, where we corely implement the curriculum aspects. So we think of what to include in curriculum and what should be the better practices to build good engineering skill, knowledge and skill among the students. While working as an academician, yes, regarding programming, especially for computer engineers, we try our level best to provide students the programming knowledge, like the language constructs. We start from first year as problem solving and programming. So at first year, it's Python introduced, and then gradually, progressively till final year, they learn various other programming languages like C, C++, Java, and all, along with the other courses like data structures, databases, networking, cloud, and so on. We teach them software engineering since last revision at second year itself, so that they understand software development life cycle. And when they implement some concept or some problem they solve using their project work, we expect them to learn and implement whatever they have learned throughout their engineering. Thank you.
So is her audio?
Varsha, madam, your audio gone on mute.
Yeah, sir, I have just briefed and done with.
Madam, may I request you to repeat what you said in the last minute or so? I think we didn't get that. If you could, please.
Yeah, so I said that, yes, we do give importance to the programming skills. We want our students to learn programming concepts. We want our students to have an ability to write codes, solve problems, and starting from first year till final year, the programming languages, other concepts, the laboratory sessions, mini projects, and projects. We expect that our students learn and able to implement what they learned using software engineering concepts and solve the real life problems. Thank you, sir.
Okay, thank you. May I now request Mr. Rahul Ekbote to give his views, an introductory statement?
Sure. Thank you, Dr. Ranade. Good morning to all. This opening statement, actually, I can, just make one, which is programming is just fun. Programming language is just fun. Okay, so I can take academician's view. I can take practitioner's view. From the industry perspective, I can add some value to the discussion. The problem that I see today that would be from the industry perspective, basically stem from where the students come from. So what Dr. Patil said is something that is sort of very close to understand how do we solve this problem. So in general, the programming languages have sort of evolved right from assembly languages all the way to modern languages. Dr. Ravindra Kumar mentioned about synthesizing languages, etc. I would like to focus only, my contribution to the discussion would be mainly around whatever I have been practicing and whatever problems I've been seeing. And I basically have been of the view that programming languages, of course, each of them solves a particular problem. But what is happening today is a trend, which is essentially you can see the evidence of having multiple programming paradigms that are occurring, and they are part of the newer programming languages. So if you look at the programming spectrum, right from CC onwards, all the way to Kotlin and Dart, that's more the newer languages, you could see that whatever started as specific problem solving, now it's become quite generalized even in programming languages, where multiple paradigms are coming into the same programming language, and we can talk more about that But that's going to be my opening statement, Dr. Anand.
Okay, thank you. Mr. Sujit Karpe.
So I'll just tell a story. So in the year 2010, if I told, let's say, to Ranade sir that all of us would have a chauffeur-driven car, let it be a kid who is like a 20 years old to somebody who is a veteran in industry 50 years old. So he would have said, it's impossible, right? How can somebody at a 20 years old afford a chauffeur-driven car? But then what happened in the year 2020, one decade later, everybody was having a Uber and Ola. And even a 20 years old kid can have a chauffeur driven car, right? And now if I make a statement that 10 years later, we all will have cars, Ubers, but there'll be no drivers, right? And then you will say it's not, it may be possible in some parts of United States or in Germany because the roads are very planned. In India, it's impossible. It may happen, right? So the problem space is changing rapidly, right? In the year 2010, we all would go to a Walmart or will go to a big bazaar to do shopping, right? Today, we do our shopping on Amazon and Flipkart, right? So the way the people are doing shopping, they're driving cars, the things are changing very fast. Technology from 2G to 4G, it took like decades to come to 4G. From 4G to 5G, we are going within 5 years, right? So as the technology keeps on upgrading, the same problem would be solved in a different way, right? Example, I have to go from a car. Car is required to go from point A to point B. Henry Ford solved that problem in 100 years ago by launching the Model T, right? Today, Elon Musk solved the same problem with a Tesla with an electric car, and when somebody's solving it with a driverless car. So the problem is still the same. I'm going from point A to point B, only the way it is done is different. And why the things are solved in a different way? Because the technology is empowering it, and technology is changing rapidly. Till the year 2010, maybe that skill set was changing every decade, right? In last decade, we saw the skill matrix changing every 5 years. In this decade, that skill matrix would change every 2 to 3 years. So whatever you had learned in the college, maybe I'm good in Java or PHP, that may get outdated in the next 5 years. And I need to keep on upgrading myself every 3 to 5 years with the new skills. So we are living in the world of the ever-changing skill era.
Okay, are you done?
Yep, done.
Okay. Okay, I think, thank you all for the opening statements. I think I would like to begin by asking, and I think some of you have touched on that already, but let me begin with the industry people right now. So do you see any specific skill shortage that you can think of? Okay, so that would sort of be of great interest to academicians, and we will have the comments from the academician and later on after you say this. But would you care to comment on? Do you think that there is a skill shortage, and give examples and maybe some ideas on how to overcome it? So let's start with Mr. Sujit.
So every company, so let's take again a problem, right? Amazon. So if you order something on Amazon, you will get a product of some deliveries within same day or 24 hours. And some product takes 5 days to deliver. And how does the warehouse management is done? Some products which are very trending, which are getting sold daily, right? Their inventory is kept near to the city where the lots of orders are coming. Right, some products which are not trending, their inventory is not kept nearby, so it takes time to get delivered. So when in a day millions of products are getting sold, what are you trying to do? You're trying to analyze the data, you're trying to crunch the data, and you're trying to optimize your supply chain for the next day or the next week. And every company is having plethora of data today, right? And data is coming from all the angles. Let it be a movie ticket booking, let it be ordering something. The biggest data is like Google Maps, right? Somebody going from a point A to point B, and continuously the servers are loaded. Then how do you find out the optimal way? So I would say each company, let it be an oil company, a food company, or a pharmaceutical company, or a healthcare, will have a huge amount of data which is getting generated, and they need to analyze the data at a very rapid speed. So every company is investing heavily into data analytics, into data science, into predictive modeling, and those skill sets are not readily available in the world today, right? Because the maybe from the academics point of view, things needs to be improved, and there's some subjects like statistics, right? Everybody hated statistics and maths, right? Some people loved it. So but for to doing massive data analytics, even the basics or fundamentals of statistics, mathematics has to be really sharpened when you're in the when you're in your age group, maybe from 15 to 22 during the college, right? So I see there's a gap between what the demand is going to be for data analytics, data science, and what we are getting as output from the academic side.
Okay, but coming to the topic of programming and languages, what kind of shortages do you see there? Or do you see a skill shortage there? Or do you think that things are generally okay?
So as like Varsha madam also said that the courses of Python are taught now in the colleges, right from the first year or second year. So I guess that's really going to help. Okay, but that's still on the programming side. But when it comes to the modeling side, I would say something on the statistics side and all need to be focused on. From the programming side, I would say Python, R, or any language which is going to be helpful into the data science or data modeling is going to be helpful.
Okay, Mr. Egbote, would you like to say something?
Yeah, sure. So I'll take a sort of different view on this in the sense that, from the industry insider perspective, if you sort of take the Indian industry, so to say, and we divide it into a product-based companies and services companies, and I have been part of both sides. I'll try to take the skill shortage problem in both of these verticals, so to say, or maybe domains, where I personally see that once you're in the product company, typically the technology stacks and the skills required are sort of bucketed. Okay, they're not, they are there, but they sort of are of a certain type. Whereas if you come to the services industry, there are completely different type of problems that you get, completely different type of skills that are required. Now, if you spend a lot of time in the industry, it is of course, easier to see how do you scale yourself in learning programming language, because that's also the other topic that we are talking about in today's thing. So in my opinion, skill shortage is there. Now, what are the skill shortages? I think, see, if you talk about something like a Scala as a programming language or Haskell as a programming language, how many people do that? I mean, I have done maybe 2 projects in last 10 years, right? So the problem is that the main skill shortage that I see is people who can scale themselves in learning programming language. So I don't want to categorize saying that, someone with C++ experience is like extremely critical, and then, having such a skill would have sort of benefited. Rather than that, I would say that if we get a people, and again, there are grades, right? Someone who is at the student level would need certain skill. So the shortages are there at almost every level. So if you're talking about up to 5 to 8 years in industry experience, where a person is expected to be mainly writing software, I see that people have a very good idea of what Django does or what Python does, but they have no idea about how a particular problem is solved using a programming language, be that C++. They have no basic concepts of the computer architecture. They have no idea about memory addressing. So the question is, while the shortages list will grow at every level in the gradation of the experienced person, is it possible that we expect to have everyone knows every other programming language? Of course, it is not possible. So what we are trying to say here is that for every level, try to find out what is the basic minimum that is the required thing. And here is what my shortlisted view on the things is. So I personally consider a programming language to be a challenge when the basics are sort of unknown. And that is where I see that rather than, and this is my experience working with academicians as well, the most of the times I interact with the 3rd and 4th students in engineering, I have always seen the examples of someone doing high-tech data analytics, high-tech vision computing, high-tech machine learning. But when I talk to them about, how microprocessors works, what is the basics of, how do you memory addressing works? Because, what we need in today's age is at every grade, something that allows the person to scale. It is impossible to have someone understand each and everything, but the fundamentals, if someone is working at machine learning in the second and third year, I sort of disagree that it's a bit difficult. Rather than that, I would rather have him focus on very basics in computers. And that is where one of the major skill gaps is. That is a direct answer, Dr. Anade, to this question. Apart from that, if you talk about specifics, right, I always have this problem of, people working with Java, J2EE. Now, if you look at the programming language spectrum, Java is getting crammed, right? It is like, the language which is getting shaped. Every year they come out with different versions. They have got so many things which are sort of crammed up. The object-oriented method or the paradigm, which is basically the core tenet of Java, is sort of now mixed up with functional paradigm principles which are added to the language. And so many other things, right? So now it is, if the original Java programmer is sort of, he himself wouldn't find out or figure out what exactly he is now, whether it's a Java programmer, whether it is, the program. So the point of the matter is, if you're talking about simple 5 to 8 year experienced person, I would rather have him focus on basics of computer architecture, either of the language. It could be C or C++. That gives a perspective on a paradigm which is object oriented. And then at some point of time, web is such a prevalent thing, and I am sorry to sort of have noticed this, that people have no idea about HTML5 itself. First, that's the fundamental problem. Why? I mean, people would ask me, why would that be a case? Why should we worry about HTML5 when there are, the tools which will allow you to create HTML5, etc. But my question is always that with all the tools and IDEs and sophisticated user interfaces, it's become challenge that people don't understand the basics on which the things are built over, and that is the sort of start of the downfall that I personally see. And then, as our discussion progresses, I can add probably more value or more discussion points on some of the items that I just sort of alluded on. But I'll just stop here and then sort of let others panelists also express their opinion. Back to you, Dr. Anand.
Okay, so maybe if I could summarize what you're saying that say something like C and C++ and good understanding of basics, good understanding of problem solving, something about architecture, and something about the web and HTML. These are sort of the major issues you think students need to be grounded on. Did I miss out anything?
Yes. No, so this is pretty much it. But then, as I said, that this is the things that are allowing people to scale. There are a lot of other areas that I can, of course, talk about. But as we sort of
progress in the programming language, in the programming language spectrum.
Correct. This is what the basics are required that are missing. As you go through different gradations within the professionals, of course, the requirements of the skills are different. And then if you talk about only the programming language itself, I am sort of struggling with having people with Kotlin or Dart or the newer programming languages, which sort of take care of the modern asynchronous programming principles and so on and so forth. But what my premise is that a person who has basics covered can pick up this language in no time. And but the fact that it is impossible for a person to know so many things today, it is, as long as someone is equipped with the tools to learn something new, he or she is in a better shape to adopt them. And that is the reason I'm saying just pick up those basic things at every level, at the student level, at the entry level into academics, and so into the industry, and then give those tools enough so that they can scale themselves. That's my point.
Okay. Thank you. Dr. Ravindra Kumar. So let me repeat the question. Do you think there is a skill gap, and let us restrict ourselves to this broad area of programming languages, problem solving? What can you say on that?
Right. So, I mean, somewhere in 2013, I attended a conference in Hyderabad, and there was a great workshop. So the crux is India is, for large, even today, is a spec-driven country. Okay, that's what the workshop put it. I like that word because India today has best programmers. Okay, I think we do have good programmers. Of course, there are gaps. But the issue is we are spec-driven country in the sense, given specs, we produce the software in best possible manner. We have all quality checks. and methods and practices. But the problem is translating a higher level problem into a software problem or a system problem is the gap. Okay, that always existed. There is always a debate why India, we don't have, lot many product companies, or as somebody asked, why don't we have Google or a Facebook in India and kind of things. The reason is maybe the nature of the industry evolution in India or whatever it is. There is India is spec-driven country, and there is a gap in that problem-solving skill. I completely agree with the views of Rahul on some of the items that he touched. Essentially, what I agree with most of his views, that what people need to know today, if you give me a programming language, I can write a basic program in this in maybe couple of days. It is not me. Any programmer you take, give syntax to him, any decent programmer can learn that programming language to write a program in a week's time. Okay, not more than that. And service industry, where which is predominant in India, where big giants like TCS, Wipro, and Infi, and all these giants are there. Day in, day out, we are in service industry, which caters to multiple domains and multiple verticals and horizontals. We expect people to be flexible in their programming languages, because today one would work on Java, tomorrow they have to work on JavaScript, or if they are lucky, or tomorrow they may even need to look at some of the COBOL code. I mean, that is a need of the hour. I mean, depending on what project, what customer problem is. So they need to be flexible in learning new programming. But as Rahul said, I think in general, having a basic concepts would help, and also the domain in which you are working on. I mean, it is often the domain that gets translated into your software, particularly be it in enterprise architecture, enterprise software, or even if you take driverless cars and autonomous vehicles and other things. It's a particular domain. Unless you have the domain knowledge, it's very hard to get right skills. I mean, one has to have that domain understanding to translate the problems into the correct software artifact. Typically, this will be an issue once the developers reach to 3 to 4 years of experience. Okay, no more. I mean, they can write programs. Okay, but unless you don't, I mean, if you don't understand the end problem, it's very hard. At least in India, if you don't understand the domain or the business problem, it's very hard for you to do that, solve that problem. Okay, so one has to have general problem solving skills. Okay, which is often I see is slightly a gap, actually. I mean, people have wonderful programming skills, though these programming skills are, as Rahul mentioned, we have programming skills, at the same time, they are most of the times, they are superficial. If you see, if you ask really how many of them really knows object-oriented programming principles or patterns, a lot of them don't know. I mean, they do code. So there are a lot of general programming tools, but they need deeper understanding of the principles, be it object-oriented principles or event-driven programming principles, or asynchronous programming, distributed programming principles. They also need to have that converting a given problem in a domain into the software artifact. Those are the kind of gaps that we have.
Okay, thank you. May I ask Professor Patil to say something I think let me perhaps summarize what has been said, and you can react in your own way, of course. I think there is some concern raised, if I may say so, that and I think you can look at, say, surveys like Aspiring Minds survey and various newspaper reports which say that Indian graduates are not job ready. So there is a lot of data of that kind. But what seems to have been raised over here is that perhaps the ability to take an informal specification, an informal description of a problem, and turn it into a rigorous, somewhat mathematical, somewhat clear specification is perhaps lacking. That's one point that has been made. And then in terms of programming experience, I think there is some agreement, it seems, that it is better for students to learn one language very seriously or a few languages very seriously rather than sort of learn too much little things about too many languages. And of course, I think there is some agreement in what has been said about there are basic concepts which relate to asynchrony, about distributed computing. Okay, all of those are, of course, fundamental. And I think new languages will come and go. But I think if you have a good idea of these basics, and if you have good expertise, experience in writing programs, and in a small number of languages, perhaps, that might be adequate. What is your feeling on this?
Thank you, sir. Yes, I do agree partly with what industry people expect, and they say that there is a gap. Industry expectations are varying, and every industry needs and technology like language specifications, maybe framework, maybe tools, expectations from students and expertise are different. If you think of academician, then we expect students to have a strong fundamentals. We try our level best to build a strong foundation. Yes, I agree that students must be expert in at least one programming language. We try that. We also expect that our students should be good in at least one programming language. So the recent revision for the same expectation, what we have done at curriculum is, at first year they learn Python, at second year C++, Java are introduced up to third year first sem, and then for remaining semesters, they are permitted to select any one of these languages which they are comfortable with, and then do the programming lab sessions for maybe systems programming, maybe data structures, maybe graphics, and their project work. So we expect them to have strong foundation, learn programming skills. So yes, we agree that initially it was noticed that students do not possess problem solving skills. So project-based learning is introduced in first year and second year, where they are not expected to build the system, final software system, maybe a IoT based system, maybe some other system, but we want them to identify a problem, analyze that problem, find out what are the requirements, like what exact expected will be an input to the system, what system should do, and what are the expected outcomes. So we want our students to do problem analysis. We do teach them, and curriculum is also including that. And for programming skills, we believe in that. I strongly believe in that programming is a skill. Coding and learning programming language is a skill, and it is something like learn driving a car. So whether you learn and drive a Maruti 800 and now you use a Mercedes Benz where it's fully automatic, it is just a question of, once the student is expert, possesses the skill of programming, learning programming language, coding and solving problem, then he can easily, given a time, just a span of 5 to say 15 days, he can easily grasp new languages, new technology, and new tools, and I'm sure our students are able to do. This is why all the industrialists who were prior the students of such academic institutes are today doing well. And we accept that whatever industry expects, and every time during revision of curriculum, we take help of all industry members. For every course design and the complete curriculum design, there are panel members from industries. Thank you.
Okay. So I think perhaps it might be a good idea to sort of get down to some concrete details if possible. So I think in terms of problem solving and programming, would you like to say something about, say, what is sort of the most complex program, say how long, and give an example of a complex program that might be written by your students, not necessarily from scratch, but in which the student has to have done a fair amount of programming on his own or her own. So I will begin again in the reverse order. So again with Professor Patil, can you say something about what would such a program be that you expect your students to have done?
Yes. Our students, like recently, 1 year back, one team we had formed, and we assigned them a problem where the set of documents, digital documents, were assigned to them. After learning after they learned the course machine learning, databases, other required courses, we assigned them a problem where a set of digital documents were given. Those documents were research papers published at one of the conferences, and the count was somewhere around 550. And then we gave them some set of topics, say up to 20, 15 to 20, and we assigned them a task that these 550 papers are to be clustered the subject domain wise. So they should finally give a set of papers saying that these are especially based on machine learning. These are specially based on, let's say, databases. Maybe few were especially based on the healthcare and IoT. Like this, they were assigned to do, and they were successfully able to do that using machine learning.
Okay. Mr. Ravindra Kumar, Dr. Ravindra Kumar, could you say, so suppose I am a student and you are trying to interview me. What would be a programming project with which you would be greatly impressed? So suppose I told you that this is a programming project that I did, and you are trying to evaluate me. So of course you have to keep in mind that there is a lot of code available, but given all these different things, can you think of a programming project which will impress you? I mean, so we could take that as an indication of what you are looking for. And I'm going to ask the same to other panelists also.
Perhaps this is very good question. I mean, it often confuses me as well. I mean, how should I evaluate particularly people whom I have to consider for research?
So, you can give multiple answers. I mean, it doesn't have to be a single answer. Yeah.
So of late, one trend that I observed, which impressed me, which definitely as a student, I never had that opportunity, is that people in that CV, they write what are their GitHub projects. Okay. Yeah. And some people said, okay, I developed so-and-so Android application. It is available in Google Store. It has so many downloads. I mean, that is very impressive. Okay. So, smart students are always selling themselves. Okay. Or they will say, this is the open source project where I contributed. I mean, they are coming up with this. So that gives me a leverage and to look at, you know, I mean, perhaps some of the industries or asking. I mean, I saw there is this company called Zerodha in Bangalore, which is, I think, very popular. When I went and looked at what kind of people they take, they said, okay, you send your resume with GitHub page. So when companies are asking, and a couple of people with whom I interacted, they also said, they wanted the people to code in front of them to see. So in a way, the way though I am still not there, but if people do some complex projects and, even at their student level, and if they contributed to open source, or their projects are available in GitHub or in the Google Play Store, or if it is a mobile app, in whatever form, that is a good indicator that they have done good work, and we can go and take a look at it and form the questions or whatever I wanted to ask based on that. Why did he think this will be the better way? Why can't done this way, kind of thing. So I would probably look at that way, because given, I mean, ideally, for the kind of work that I do, there are some specific skills required, but I may not get. But what I evaluate is whether, if I take this guy, can I mold him in 6 months or 3 months into what I want? So I look at from that perspective, whatever he has done, is it, does it reflect his skills? So that's how I look at it and evaluate.
Okay. Mr. Egbute, would you like to say something?
Yeah, sure. So again, it's a good question. And then I have been actually working with all grades of people coming in. And I would like to take some examples in terms of what I would look for each grade, not necessarily only at the entry level. And in the audience, students, we may have different type of people. But at least, from my interactions, if you ask, if someone who is fresh or maybe one year experience, 2 year experience comes, and then talks to me about some basic things, right? So in continuation with some of the concerns that I had raised in my earlier discussion about the getting basics right rather than getting tangled into the mess of app reduces and artificial learnings and very complicated stuff, I would rather ask the person, okay, you understand object-oriented concepts, so give me some understanding of what an instantiation of an object means in terms of the programming language, or in terms of when you do it in C++, you say new, or when you say malloc in C, or whatever specific syntax you have per language, what does it mean? And what actually happens? And then, take it from there. So I also normally also look at data structures algorithms from the complexity, which are typical favorite questions. And whatever Dr. Ravindra Kumar added, those are sort of additional feathers that, sort of add more value, whether, someone has done some GitHub projects, someone is doing some open source contribution. That's at the developer level. So where all the grades, my specific criteria right at the beginning is only to see the basics. Now at the developer level, I told you about object-oriented paradigms. Today, mostly many people have done some sort of functional programming at the level of college, but I don't expect that someone does that, someone knows it, someone can explain it. That's like an added advantage that I look for, additional pieces that give me an indication that there is something interesting apart from mundane stuff, actually looking at that. So at the level, as you go progress, because I've been doing mainly the architectural work, as you progress on the ladder of developer to senior developer, and you sort of add more sort of gray hair to yourself by doing a lot of complex work. At the architectural level, let me give you a very, sort of somber scenario, right? In all my architectural discussions, I ask questions, two questions, that if an architect knows about, everyone does browsers, everyone knows what the sort of security means. So I asked the so-called, the applicant who wants to be part of the architecture team to say, what is that, what happens actually when the browser decides that this particular site that you have been referring to is secure or not? So what actually happens? So people tell me about TLS and HTTPS and many things, but then people have no idea about public infrastructure. They have no idea about certificates. They have no idea about where to get certificates from. How do you configure them for different things? So again, if you look at this whole pattern, emphasis is on basics, not on any complex magic or any complex discussions on things. And that is typically my trend of looking at every level, whether that's a 1 year fresher person, 5-year person, 8-year person, or 15-year person. The gradations and the sort of problem statements will change a little bit, but the underlying point would be basics.
Okay.
Thank you.
Okay. All right. Let me just add one question to it. I think a number of people in this group have talked about C, C++. Do you think that is a reasonable clubbing together? I mean, you would think that C++ is a much more evolved language today. And say, for example, very simple things like data structures. So really good data structures are available. So do you think that if somebody says that I do all my programming in C versus I do all my programming in C++, is there a difference? Would you sort of prefer one over the
other? Shall I go ahead?
Yeah, please.
Oh, okay. So no, I mean, yeah, see, there are again two things, right? In case of conceptual understanding of object-oriented programming languages, which is still implemented in Java and many other languages, C++ is probably the earliest in that cycle of implementation from the object-oriented perspective. I don't consider, the differentiation in engineers as far as the C and C++ sort of division is concerned. Yes, paradigm-wise, yes, one is giving sort of a different picture in terms of how you can solve the same problem. But if you look at the first point that I ever made, if you really ask me, even before C++, I would rather say that, this computer architecture and then using of assembly. Now, again, many people in this audience may feel that we are in 2021, why we are talking about even assembly language, but I feel perplexed that people have no idea about pointers in C and the references in C++. And I don't see necessarily a better way than giving, once the assembly language is sort of understood, what does it mean to take an object and say, this is how exactly it looks like in memory, for example. I mean, this is what the fundamental things are required. So C has got its own points that I think are required when you say object-oriented design, let's say in C++, but then how it is implemented as a virtual sort of inheritance, and how does that happen? And then a picture or to the student which says, this is how it looks like in memory, by the way, that once you define an instance of derived class, which is based on the base class, but actually you're trying to create a point to the base class, but this is a jumping point. I know, in the audience, many people will be perplexed even today, especially students. So how do you solve this problem so that a person has no idea, no problems in terms of either pointer or reference or pointer to pointer or dynamic, whatever it is, like virtual inheritance, nothing like that. So no problems as far as whether someone says I have understanding C++ understanding, if someone says C expertise, I would say, okay, let's talk about pointers, let's talk about function pointers, let's talk about code sections, data sections. If someone talk about C++, I would rather have him discuss about object-oriented principles on the similar lines that I mentioned in C.
Okay. Mr. Karpe, would you like to say something? So again, let me repeat the question. So do you have a favorite application that suppose somebody comes to you and says, look, this is what I have done. And based on your understanding of how much of that could have been done individually by that person rather than by assembling code or whatever. I mean, even assembling code is useful, a very useful skill today. But what would impress you? So again, in terms of that would be sort of a desirable graduate. So what is a desirable graduate in your opinion?
So after 4 years of education, if somebody comes empty-handed for an interview, that's really not expected, right? So if somebody, because today so much of things are available, right? So if somebody really comes with like for an interview saying that I've developed this mobile application, right? Please have a look at it, or a GitHub repository, right? So if the conversation starts at that note, that I've developed something with all my experience and my whatever I've developed, I have like a testimonial to like a real thing to show, a GitHub repository, and it does these things, or a mobile application. And once somebody shows that, I think that's a really credible thing. Now, based on whatever he has shown, right? if he can explain a few things which I always ask candidates is, how have you implemented OOPS concepts over there? Because I think having what Rahul said, right? Having the understanding of OOPS concepts is very important. Data structures is very important. And then the third thing I usually try to understand from them, do they understand scalability, right? When I say scalability is like in college, I remember we would solve a 2x2 matrix and n by n, and n by n was always difficult to solve in programming, right? In C++. So what happens is the moment the scalability comes, have you really thought about it, right? Because people can write code, but sometimes those code are not able to scale, right? So I look at, do you have something to show? So if there are students in this right now hearing, so the key takeaways are, if you have something to show, it can be a mobile app, a GitHub repository. Are you good in your OOPS concepts, in your data structure? And can you show scalability in your application? And when the something starts on scalability, then everything gets unveiled, right? Your architecture concepts. Do you understand computer at the basic? Do you understand networking? If somebody just comes and says, hey, I've hosted a website. Wow. Did you host a website on GoDaddy? Do you have SSL certificate? How did you download the SSL certificate? So there's so many things I can ask him in the interview process, and I really get to know that all his education, what he has done, he has packaged into something which can be like a testimony of his knowledge.
Okay. I think let me move to some of the questions that people have asked. I think there is a question, just like we don't learn to drive automatic shift car to begin with, should we not teach programming with basic programming languages like C, C++? Okay, so that is a question that Professor Venkatesh Kamath has asked. Anybody would like to give a quick opinion?
So I'll just give a quick opinion. I've already sort of alluded to that. I won't even mind going to assembly language for that matter. So
okay. Mr. Ravindra Kumar, yeah. Do you have a favorite language with which you would like students to start their programming journey? Okay, Mr. Sujit.
So I started my journey with C, C++, then Java, then I was working with SAP also sometime after IBM, then SAP, and then Microsoft Azure Cloud, and it has been a lot of things on the cloud now. So I would say my favorite is C and C++, because you will change your language every 2 to 3 years. So if your fundamentals are really good, you can pick up anything. So be strong in, let's say, between C and C++, preference it would be to C++ because your object-oriented concepts really become sharp, right? So between C++, my preference is with C++. Start your career always with C++.
Okay, Dr. Patil, what would you like to say?
Yes, sir. We also expect students and we teach students C. So even I want students to start learning from C or C++. C++ they grasp faster. Our experience says that when we started with teaching from C, the students weren't that comfortable and there was a programming fear because it is for all branches. Initially, at first year when we start, it is for all branches common, not only the IT engineering. And then 3 years back, we started with Python and simple problem solving skills and then switched to C. I realized that students are more comfortable in learning programming. Python makes them more comfortable in programming, and then they can easily switch to learning C++ or C.
Okay, I think we are coming to the end. I think as I look at the questions that have been asked, I think they have been by and large answered. I think Ms. Sonia Garcha is curating the questions for me. Okay, she has put one more question. Looking at programming language as a tool to solve the problem, is there a need to focus on giving student exposure to realistic problems and making them work in teams and learn good design, good programming principles and testing and development? Okay. I think the answer to this is going to be yes. I don't think anybody is going to say no to this question. Let me try to. I'm going to ask a question And I think since we are getting close to our scheduled end time, I think I would like the panelists to give their closing remarks. But let me ask the question which they could perhaps answer along with their closing remarks. The closing remarks could be what they have learned themselves, and if they want to respond to what the other people have said. So I think there is always a case to be made for students to learn a lot. Okay, but it's simply because I think new languages are coming up. In general, the knowledge that humanity has always been increasing. But at the same time, I think there is a limit to what can be absorbed by a student in a 4-year program. Or for that matter, there is a limit to what a student can absorb in the 10 years of schooling. So I think perhaps it might be a good idea if you can spell out and say, what do you think can be thrown out from the program? Are there things that you think should be thrown out? And let me start this from Dr. Patil. Do you think that there are things in the program that should be thrown out, and have you made attempts to do that? Or you think that we just have to live with the knowledge that is gaining and somehow burden our students more and more?
I don't think there is something which is to be thrown out, because a student gets 4 years span. If we think of computer engineering or any other engineering, then they get enough time to build their skills. So starting from the basic programming languages like programming skills and some programming language, let's say C or let's say Java. So teaching them what are the programming concepts, how to solve small problems to the complex problems, writing programs to solve those problems, taking them to something like basic frameworks which industry expects is something like Spring Boot or Hibernate. So nothing is to be thrown out. Learning one programming language and having programming skill developed makes students to learn any newer language and switch to any newer framework very easily.
Okay, Mr. Sujit, would you like to throw out something, and would you like to react to what other people have said?
So I would say we expect too much from students in the 4 years of program, and if we can make it more object oriented, right? We like object oriented languages. So why not the world can be object oriented? And when I saw object oriented, maybe I'm a good artist and I'm a good at design, right? So can I really pick up HTML or maybe Angular, anything in the front end languages, or even going to design, Adobe, Photoshop, Illustrator, and let's focus my 4 years only in that. Let's say even if I'm doing front end, starting with HTML, JavaScript, Angular, React, and I'm become an expert on that. I really don't care what is C, C++ or assembly, right? Versus somebody who is very much into a backend programming, focusing on maybe C, C++, Go language, right? And really Java, getting into that. Somebody who wants to make his career in data because he's very good in statistics, only focusing on Python. The world would be much easier for the students, and it also would give a tremendous ROI for the industry because they're getting people who are experts in something, right? Will it impact them 5 to 10 years later as the things change? I would say really not, but the life for students would be very easy because else they are learning so many things. And at the end, we hear a remark from someone that there are so many engineers in India, but they're not employable. Why? Because they're learning everything.
Okay, Mr. Rigbote.
Yeah, so I mean, to make it really brief. So first of all, starting, any programming at the first year engineering, in my opinion, okay, that's maybe the I think earlier you start is okay, but academically speaking, if someone says that I want to do 4-year engineering, first thing that I would, again, I know that a lot of common subjects in most of the computer engineering, thermodynamics, and some applied mechanics and things like that. But keeping the discussion to the only programming part, I would throw away AR/VR, throw away big data.
You would throw away what? I'm sorry.
I would throw away AI/ML. Okay, I would throw away big data. Okay, I would throw away AR/VR. Okay, augmented reality, and so those topics. And because this itself will sort of reduce burden on the students and make them focus only on basics, at least for the first 2 years or so. Remaining 2 years can be given only to the programming paradigms specifically that are in use today, which are typically two, which is object-oriented and functional. So both of them are now sort of incorporated in most of the today's languages, which are sort of, I think. And then in addition to that, something which is practical, creative oriented is what I would recommend as a sort of thing to do for the engineering curriculum.
Okay. Dr. Ravindra Kumar?
Yeah, I mean, I think first 2 to 3 years, I think basics are very important. So basic one programming language and focus on, problem solving skills. Essentially, we have this in our mathematics, if you look at ICSE syllabus and something where we have a lot of statement problems converted into equations and solve it. Similarly, some kind of high-level problems translated into programming languages. I mean, that kind of thing, you keep it and move some of these advanced topics like AI and ML. Don't teach them more like a programming language. I mean, teach them their concepts. Okay. And keep it everything at some conceptual level, or teach concepts and then their application. A blend of that is required. I mean, I didn't get a chance to look at recently any curriculums in deep, but this is what I would like to keep it as.
Okay, I think we have slightly overshot our time. I think we have had a very nice discussion. I think perhaps if I may state some of the conclusions, I could paraphrase those as saying that we need a certain amount of depth. I think we probably need to teach the students how to learn, so that they can do lifelong learning perhaps. I think object-oriented languages and functional programming, the concepts of object orientation and functional programming are here to stay. I think it has been said that data and ML and AI are important, but of course that's somewhat outside the scope of our discussion over here. And I think I should probably end this by saying that this is, of course, a really complex, difficult topic. And I hope we can have more discussion of this kind, I think, where, say, we can sharpen, we can have more sharp demands. So industry could say that, look, we really think that this is wrong right now. We really think that academia need to correct these things. And at the same time, perhaps academics could come out and say, look, we are really confused about whether we should be teaching this or whether we should be teaching that, or we are worried that our graduates do not get enough exposure to industry style problems, and could you help us regarding that? I think those are kind of discussions that perhaps we should be having in the future. But I think as a first discussion, perhaps I think we have made perhaps a reasonable beginning. So I think with that, I think perhaps we should conclude this discussion. And I will hand over back to Mrs. Geetanjali Kare.
Yeah, thank you very much. It was really the insightful panel discussion. I think Vivek has something to say about this. Yeah. So, Mr. Vivek.
Yeah, hi. Thanks all. Before actually we express thank and talk about the thanking all of you, I just want to highlight one point here. In fact, today's Times of India editorial there is a article on called missing skills. In fact, this in what they state in that is what Dr. Ranade was saying about the Aspiring Minds report. In fact, the one which concluded in 2019, that particular report said that employability of Indian engineers in India has not changed at the aggregate level since 2010. And one of the other argument is that 44% engineers are employable at software startups. Now, this is then they also mention about this industry academic relationship has to be, in fact, it has to grow further so that we can address this particular problem in a much better way. And that's what I wanted to highlight. So please look at this particular missing skills TOI article, and definitely there are many more things that we need to really look at and do to bridge that gap. And skills is one of the gap that I feel is definitely we need to bridge as early as possible. That's what I wanted to say. Over to Nitin, please. Thank you.
Hello everyone. Myself Nitin Patil, Assistant Professor Computer Science and IT Manager at Savitribai Phule Pune University. Please join me in thanking this fantastic panel who gave all of us an insight and enlightened us with respect to the viewpoints related to academia and industry perspective related to programming. I, as a treasurer of ACM Pune Professional Chapter, would like to thank Professor Abhiram Ranade sir for accepting our invitation to moderate this panel discussion. I also would like to thank two panel members, Dr. Ravindra Kumar, Sri Sujit Karpe, Rahul Egbote sir, Professor Varsha Patil for accepting our invitation and actively participating in this panel discussion. I also would like to thank all the participants from academia, software professionals, industry, and all other members from ACM for making this event successful. Last but not the least, rather, I would like to express my vote of thanks to the volunteer students from PICT and all ACM Pune Professional Chapter members to make this event a successful one. Thanks again. Thank you very much.
Thank you.
Thank you very
Thank
much.
you. Thank you
Thank
very
you,
much.
sir.
Thank you.
Thank you.
Special thanks to all the panelists and attendee. Thank you.
Yes, thank you.
Thank you, ma'am.
Thank you, everybody.
Thank you, sir. Thank you.